students, today we see previous iit-jee questions in the topic classification of elements. That is the periodic classification of elements. See the first one, that is according to periodic law of elements, the variation in properties of elements is related to their. Here, what is a periodic law? The periodic law, first periodic law is introduced by the scientist Mandel. Okay, what he explained a periodic law means the physical and chemical properties of elements or periodic function of their atomic weights. That means if we arrange the elements in increasing order of atomic weight, after a certain time period, the properties of elements are repeated. The properties of elements are reduced by the Mandel. After that, after that Bohr give a different periodic law. Now we follow a long form of periodic table. That number. What is a modern periodic table or modern periodic law explains? It explains the physical and chemical properties of elements or the periodic function of their atomic number. It was explained by the scientists mostly. Okay, see here according to periodic law of element, the variation in properties of elements is related to. Here he don't mention which periodic table, but we will take a long form of periodic table. Now we see a long form of periodic table. In that periodic table, elements are arranged in the form of a atomic number, increasing order of their atomic number. After Bohr explained the periodic law, that is a physical and chemical properties of elements or the periodic function of their electronic configuration. But it is failed in a chromium and copper. So mostly we will take a periodic law means the physical and chemical properties of elements or the periodic function of their atomic number. Okay. So remember this one. According to atomic number, elements are arranged in a tabular form. Okay. Good. The second one. See, an element having an electronic configuration 1:2, 2:2, 2p6, 3s2, 3p1. Here, the outer electronic configuration or valence shell configuration is a 3s2, 3p1. 3s2, 3p1. Students, periodic table means every time carrying a periodic table is a very difficult. So, in your mind, you will remember in a short form, that is, see, the periodic table mainly is divided into three parts. One is the extreme left side S block. It has two groups, 1A and 2A, and extreme right side P block is there. P block elements are arranged in a right side of the table. Here in a P block we will see third A to 8th A group. 8th A group. In between SM P block elements, D block elements are arranged. D block elements are arranged. Here the D block elements are arranged in a third B to second B. Third B to second B. Here third B to 8th B are arranged after 1B and 1B and 2B are arranged. Okay. See here S block, P block and D block. Here the F block have two series of elements, 4f series and 5f series elements. Those two series of elements are arranged below the periodic table. Below the periodic table. This is the F block. Here generally the S block elements are metals and non-metals. Metals only. S block elements are metals. The first A group elements are called the alkali metals and second A group elements are called the alkaline earth metals. Alkaline earth metals. And the P block elements, each group have a different name. The third A group has, that is a boron family. Boron family. Whatever the starting element, the name is given to that group. Okay. If the first element is here, in the third A first element is a boron. So the group elements are called as a boron family. And fourth A is a carbon family. Fourth A is a carbon family because the first element is a carbon. After the next, the nitrogen is known as a nitrogen is the next fifth A group elements. The starting element is a nitrogen. So the elements are known as a are called as a nitrogen family, and those are also have another name, that is a pincogens. What is that? Pincogens. And sixth A group elements, those the starting element is a oxygen. So that's why those are known as a oxygen family. The group elements are known as oxygen family, and that oxygen family is also known as a chalcogens. Chalcogens, because chalco means they are present in a ore. That means oxygen group, whatever the oxygen family, the elements are a more reactive one. So ore generating one. Chalcogen means a ore generating one. Okay. Maximum the metals are extracted in the form of ores. Okay. In that ores, the metals combines with the oxygen, because those are the most active reactive elements. So that's why these group elements are known as the chalcogens. After that, fluorine. Fluorine group, 6th, 7th A group elements are known as a fluorine family. Those are also called as the halogens. What are those? Halogens, because those are extracted from our sea salts. So that's why those are called the halogens. And the last group, 8th A group, or the starting element is a helium. These group elements are known as a zero group elements or inert gases or noble gases. Okay, that group has so many names. 8th A group, and according to the number of groups from left to right, it is the 18th group. So that's why 8th A group or 18th group, or those are called inert gases and noble gases, because all the group elements are gases. So that's why those are inert gases, noble gases, and zero group elements also. Those are also called zero group. Why those the group elements have different names? Because the last group elements have a general configuration NH2 NP6, NH2 NP6. Due to the octet configuration in the valency shell, their reactivity is a zero. That means they does not involve in the bonding with the other atoms, that means reacting with the other atoms. So due to that zero reactivity, the elements are known as a zero group, and sometimes those are called as a inert. Inert means a lazy. Okay, so why they are not involving a chemical reactions and reacting with others, so that's why the elements are known as a inert, means a lazy. Okay, and also are stable, that due to stability, the elements in the group are known as a noble gases. Okay, and one more thing, the S and P block elements are combinedly known as a representative elements. What is that? S and P block elements are known as a representative elements, and T block elements are known as a transition elements. Transition elements, and F block elements are known as a inner transition elements. Inner transition elements. Okay, the S and P block elements are known as a representative elements, and T block elements are known as a transition elements, and F block elements are known as a inner transition elements. S and P block, the representative elements, have a configuration NS1 to 2, NP1 to 6. Okay, those have a NS1 to 2, NP1 to 6. Combinedly, the S and P block are known as a representative elements. Okay, the D block or transition elements, they have a configuration n-1d 1 to 10, 1 to 10, ns2. The A block have a general configuration n-2 at 0 to 14, 0 to 14 and n-1 d 1 0 or 1 0 or 1 ns2. Here the transition elements means those are in between the S and P block elements are known as the transition elements. Inner transition means the 4f and 5f series we will see in a 6th period and 7th period of a periodic table. In a D block, D block are called transition. Those are placed in a transition element. So that's why those are known as a inner transition elements. Okay. So see the configuration of a given element. That is 1:2, 2:2, 2p6, 3:2, 3p1. Here the valency configuration is a 3:2, 3p1, 3:2, 3p1. Here the last electron is present in 3p. So that's why the element belongs to P block. The element belongs to P block. What is the blocks? Is block, P block, D block, A block. In which orbital? The last electron enters into S orbital. The element belongs to the S block. If the last electron enter into P orbital, the element belongs to P block. If the electron enter into the D orbital, last electron enter into the D block, the elements are known as the D block elements. If the last electron enter into F orbital, those are known as the F block elements. So here, according to the last electron is present in 3p orbital. So the element belongs to P block. But here in options, no P block. And next one, S and P block elements combinedly known as representative elements. See, first one an inert gas, second one transition element, no. An inert transition elements, no. A representative element. According to the outer configuration, the electron is a P block element and the S and P block elements are known as representative elements. Okay. Inert gas means only in a 8th A group element and a transition element means a D block elements. Inner transition means a F block elements. S and P block elements combinedly S and P block element are known as a representative. Next one, the long form of periodic table. All the non-metals are placed in. Now only we see the S block is the left side, P block is the right side, and D block is in between S and P block, and A block elements are below the table, periodic table. Here S block is in a left side, P block is right side, D block in between the S and P block, and A block is below the periodic table. Observe, the S block elements are completely metals, and D block also metals, and F block also metals. That means 80% of a periodic table, nearly 80% of periodic table is occupied with metals. In a P block, we observe metals, non-metals and semi-metals. Semi-metals are also called as metalloids. That means so they have both some metallic characters and non-metallic characters. Okay. Here also the non-metals are only we observe in a P block. Okay. S block, D block, A block, completely those are metals. In a P block, we observe all the three types of elements: metals, non-metals and metalloids. Okay. So here he asked there, in the question he asked the long form of periodic table, all the Non-metals are placed in which block? Those are placed in P block. And see the next one. An element belongs to 15th group and third period of periodic table. Its electronic configuration will be, okay. See, from left to right, the periodic table is divided into 18 groups. What are those? 18 groups. Those in 18 groups, two groups are S block and 10 groups are D block and 6 groups are P block. Okay. Totally left to right periodic table is divided into 18 groups. In those, 2 groups are S block, 10 groups are D block and 6 groups are P block. Here the S block elements, 2 groups are also represented 1A and 2A. 1A and 2A. D block elements are third B to second B. Third B to second B. And the six groups P block elements are represented with a third Roman number 3A to 8A. Okay. So see, first, second, and that means 12. 13 to 18th groups. Okay. See, 15th group means, see the one, 5. 5th A group. Okay. 11 means, the 1A groups, 1A, first one is also 1A. Second group, 2A. Third A is a 13th group. Fourth A is a 14th group. Fifth A is a 15th group. So, see this number. Okay, now before that give a 1 in a normal numbering. Okay, numerical numbering. And Roman numbers, 3rd A to 8th A. So, 15th group means it is a 5th A group. 5th A group. First A means it has a NS1. Second A means it has a NS2. The 5th A has a NS2 NP 2. Okay? 2 minus 5. 5 minus 2 is a 3. So, NS2 NP 3. The 5th A group or 15th group have a configuration NS2 NP3. That is a valency configuration. Valency configuration. And here one more thing he said, third group. Third means the n value is a 3. N value is a 3. So that means the valency configuration of a 15th group third period element is a 3s2 3p3. 3s2 3p3. Check the options and which one have a 3s2 3p3 valency configuration. Okay. So here C 1s2 2s2 2p6 3s2 3p3. That means if you know a group number and the period number, you will readily write the configuration, valency configuration. Check the valency configuration and write on a correct option. See, 15th group means the 5th A group. They have a configuration NS2 NP3. Third period means the n value is a 3. So 3s2 3p3. Okay, simply like that you will write.